I'll pay you your commission later for the compliment. Okay. So hello everyone. Today we're going to talk a little bit about Web3 security. I'm going to keep it light, so if you don't have deep technical background, don't worry. This is supposed to be fun, engaging, informative, and we'll dive more into the security side than perhaps you've seen before, but hopefully in a relaxing way. So world's fastest intro. I'm engineer, and I do, or maybe did, security at Y Audit and Y Academy. So what we're talking about today is basically security, a bit about the landscape today, some of the misconceptions that a lot of people have with security in the space, and also why it's hard, because it's not always immediately obvious what makes this topic hard. So security in the space, I mean, if I was to ask any one of you what you've seen about security in Web3, maybe it's something like this, just hypothetically. What's this? Yeah, it's not so great. It's like when you see a headline that's like 100 million gone in a single incident, that's, we'd prefer not to see these headlines. And then you see other ones like, oh, it's actually 167 million on this other one, and oh, we got a few more, 195 million, and oh, only 8.5 million. That's chump change. Like, you can't even live off this. I don't know if I can buy a hamburger. And then 6 million, 182 million. And you know what? I'm not even getting creative here, because every single one of these headlines is with the exact same attack vector. It's like I'm not even looking about general attacks. I'm just looking at flash loan attacks alone. So this is how bad things are, where a single type of attack, you can have, I don't know, are we looking at like half $1 billion gone, basically? Yeah. So half a billion with a single attack vector. Yeah, it's probably more. I mean, now it's about like 3 billion just in the time since we started. So anyway, this is probably what you see. You just see like everyone's doing a really bad job because you see the headlines. But this is not the full story, and we'll talk a bit more about the story today. But this is probably how you feel when you hear security. I'm sorry. It's just how it is today. So first, let's get into a bit of the history, because security in the space has changed over time, and even though you still see all these headlines of hacks happening, I want to explain sort of the maturity of the space now as opposed to 4 years ago, 5 years ago, when it was still very early. So in 2020, we have everyone's favorite website for hearing about hacks, rect.news. If you are not familiar with this website, I would recommend looking it up, because they have very entertaining, humorous write-ups of hacks when they happen. And DeFi summer begins. DeFi summer is when a lot more DeFi protocols started getting deployed on chain, and that also meant a lot more money coming on chain, and therefore more incentives for people to try and hack these projects. And of course, when there's only 5 projects on chain versus 500 projects on chain, 500 projects is a much easier target to find the weak link to try and take money. So really, 2020 is, you can say, when things started getting a bit more important for security, just because there's more projects on chain. In 2021, people started taking some action on the security side when they started seeing these hacks. Code Arena, which is a platform for crowdsourcing security vulnerabilities. Some people call it a crowdsourcing audit platform, whatever you want to call it. That started in 2021. And one very famous security researcher, Sam CZ-Sun, started publishing a lot more in 2021. Again, if you're in security and you haven't read all his articles, I would highly recommend it. Even if some of the write-ups are a bit old now, there are still very valuable lessons in there. So 2021, it's after all these projects started deploying on chain, and people start realizing this is important, hacks are happening, maybe your money in the protocols is not safe if you're not paying attention to security. In 2022, there was a lot more focus on security. I would say between 2021 and 2022 is when I entered the space, and 2022, it was definitely a growth year. A lot more protocols started realizing they need to do an audit. This was not really a given before 2022. Doing a security audit was maybe a bit optional, a bit of a bonus, and 2022, people started catching on. If they don't do an audit or have some security people give their input, there can be some dangers there. So this is the year when if you wanted an audit, you had to wait maybe 6 months, maybe 9 months, which is actually very ridiculous because crypto moves so fast. No one is going to wait 9 months. You'd rather just ship it and then do the audit later, and that led to more problems. But anyway, 2022, I would say, is when people started needing security, but there wasn't enough supply of security people. But things change because crypto changes and crypto moves very fast. So in 2023, more security people started popping up. Because security in this space is so new, if you had like 2 months experience, you could already get a job, which is probably a bit dangerous, but that's just how things were at the time. So 2023, I'd say a lot more supply of security knowledge got onboarded to the space, which is great for the space as a whole. Because the more people who know how to stop the hacks, the better for everyone. Users, developers, everything. And then 2024, where we are today, I would almost say that there's like so many people that decided to shift towards security that maybe it's actually getting a bit crowded, especially because we don't have quite the DeFi summer bull market as we did back in 2021. So now the audit backlog is very short, even at some of the most popular firms, less than a month for the backlog. There's many audit firms. I actually often get asked, do you know about this audit firm? And I often reply, I've never heard of that name. Like, when did they appear on the scene? So there's just a lot more security people, is all I can say. I can't speak to the quality of all of them because clearly I don't know about some of them. But this is just a bit of a timeline. We don't know what's happening next year. I don't even want to guess. But I just want to share that things started from the perspective of we don't even know we need security. Some people came along and said, security is kind of important. Might want to look at this. And then security people started getting onboarded into the space, and now it seems like we have a better balance. So hopefully, going forward, we see fewer headlines, or at least headlines with, let's say, smaller figures, ideally. Whether that's going to happen, I'm not placing my bets, but let's see. So when you hear security, you might have a vague notion of like a paranoid guy in a basement wearing a tinfoil hat, but there's a few different characters that might work in Web3 security, and I just want to introduce the cast so that you have a bit better understanding of if someone says they're in security, which bucket you can place them. So first, perhaps the most common is, let's say, a smart contract auditor in a company or a DAO. Their job is just to read code, basically. If you think of a book author as writing a book, an auditor is the book editor. So they are reading the code, they are circling the mistakes, and they make sure the developer fixes those mistakes before the book or the code is published. Now, a security engineer is a little bit different. There actually are not too many of these yet in the space, but some large protocols, I would say mostly layer 1, layer 2 chains, have an internal security person, and their job is to provide guidance on the architecture design to keep everything secure. So they're like internal to a project. The auditors are usually an external person that you hire. Solo auditors, if you're on crypto Twitter, you've seen these people because they are way too loud. Just someone make them shut up. But the reason they're loud is because they have to do their own marketing because they're just like a single person. So the reason you see them shouting on Twitter all the time is because they have to do this business model. And then the ones you don't hear about almost ever are the bounty hunters. They just sort of lurk in code bases looking for bugs and then report it to a bug bounty platform. So they actually don't want to share their methods usually because they're trying to race and beat everyone else to finding a bug in some code base. So anyway, these are the different characters you can meet in the space, and I just wanted to share this in case any of you are interested in the security side, perhaps want to try and fall into one of these buckets in the future. And let's do an honorable mention, something that hopefully everyone here will learn about or pay attention to because you might need it in the future. SEAL 911. Can we see a raise of hands? Who has heard of SEAL 911? Okay, great. I'm glad I am bringing this up This is basically a team of OG volunteers, like very smart security people in the space, and completely voluntarily, they have created, let's say, a helpline. So if you have a security vulnerability in your protocol, you can just reach out to them and say, like, help, I don't even know what I'm doing, but someone's hacking my protocol. Or like, we just learned about a crazy bug and we don't know how to fix it. So these people, being experts, are sort of running around everywhere in the space trying to put out all the fires. It sounds like it's a very hard life for them because it sounds like there's a lot of fires. But if you have a problem, this is a resource to know about. So that's why I wanted to share this. If you want to volunteer putting out fires in the space, maybe you can also contact them. They're very busy. Okay, why is security needed? I don't even know if I needed this slide, but I thought, let's assume zero knowledge. So every line of code should get some review because even changing one line can make the entire protocol insecure. It might sound hard to fathom until you understand the flow of logic always goes through certain paths, and if you just change the way it works in one place, everything can be bad. And obviously the stakes are high. This is why we have these sad headlines of 9-figure hacks happening now and then. And when the stakes are high, then there's many black hats that would love to grab the free money out there. So we need to try and prevent against this. So, some misconceptions of security. If you hear solo auditors on crypto Twitter, they're going to pitch that their audits are bulletproof. I'm going to tell you that's definitely not true. And there's some protocols out there who have done 10 audits or more for the same exact code base, and the different audits reveal different issues. So there's no such thing as a bulletproof audit. All that you're getting is some comments from someone who knows about the subject. So, but anyway, that's the best we have today. Hopefully we'll get better in the future. So I'm going to go through these misconceptions, and I want you to also think if you have any questions or misconceptions or even comments about security in the space, because afterwards we'll do a Q&A or ask me anything, and you can pitch some question or prompt, and you can get someone to give an opinion on it if you want. So anyway, I'm going through these one by one. First, security is so hard to learn. It's so complicated. There's crazy hacks and bugs in every direction, and I'm not going to tell you it's easy, but I'm going to tell you there's pathways to get there with incentives. And learning from a book is pretty dry and boring. I don't know if any of us want to go back to school. Anyone? No? No hands? Okay. But what if you were getting paid while you were learning, and it's not from a book? It's actual code, and you can actually help people while getting paid. So this is what we have in this security space, is we have these contests. So I don't know if any of you in the back can see, but I'll just read out some of the numbers here, the prize pools. We have 20K, 70K, 60K, 200K, 12K, 15K, $500,000, 89K, another $500,000, 150,000. So yeah, with numbers like this, it's a little bit of an incentive to study. If you can get, you probably won't get all the $500,000, but let's be optimistic, maybe you will. So if you can learn about security, apply your knowledge, and get paid on the way, then really there is almost no barrier to entry. Because usually the barrier to entry is you need to study for a long time, and then you get paid. But in security, you can get paid from day one, your first day of studying. So I would highly recommend, if you are interested in this topic, it's worth considering the contest route as a way to study, apply your knowledge, and even in the contest results, you see how you stack up against other people. So this is very cool, and the fact that even these contests, usually you don't need to KYC, it's literally no barrier to entry. You may as well try if you're interested. It does take time. You're probably not going to get much money in the beginning, but it's still entertaining, as long as you're okay with some early failures. I will say there's also different groups that have trainings. I will show Y Academy, which I've been part of, and Securium have these basically free trainings that you can enroll in and learn more about how to find these bugs. So maybe hard to learn, but you have incentives, and there's so much open source free knowledge on the internet for this subject that it's very doable. Okay, second misconception, you have to know all the hacks ever, like encyclopedia knowledge, full recall of everything, and I don't think anyone has that in the space. I will even tell a little funny story from one audit I did. We just onboarded a new guy, and we had this new guy on the audit, and the new guy wrote up an issue, and the other person who is not a new guy on the audit with me was like, have you ever seen this type of issue? Like, what did he write up? Is it a real issue? And I started researching. I'm like, oh, yeah, I saw this on Twitter like 3 months ago. I didn't think it would be like a real thing you would find. So this new guy who just like joined the team was already finding stuff that I had at least seen somewhere, but I never looked into it deeply. So yeah, no one knows all the hacks ever, and everyone brings their own knowledge to the team. And this is why it's very important to have more than just one person look at code. Because for example, pick a hypothetical person, they might have really good knowledge of like economic attack vectors, but then someone else is really good at math, and someone else just knows about crazy reentrancy attacks. All these people have different skill sets, and it's like any team. You want a team that balances itself out with good knowledge. So yeah, the other points here, you can even just focus on a very specific type of bug and succeed. You could do this with the bug bounty approach to finding bugs, or with the contest approach. Because both of those, you don't need to find all the bugs, just some. Now auditors working in a company do want to find all the bugs, ideally. Yeah, this is actually what I just said, so I won't repeat myself. And many hacks are just known issues. So you can actually look at a giant list of past hacks and go through them one by one. This GitHub repository is excellent because it even has a proof of concept of how to execute the exact hack that stole money. So if you were to have a time machine, this repository would be worth like billions, basically. So anyway, would highly recommend it. In fact, I would say if I was starting from scratch today, I would heavily rely on this as a learning resource. It's a stressful job. Yeah, well, the 21-year-olds would disagree. But I would say this isn't completely true. Like a lot of these misconceptions, there is definitely some truth to it. Not completely true, but I'll say it's different types of stress for each of these security characters. So for the auditors who have to find all the bugs and like say this code is secure, you're always in fear of like missing something. Because if you missed one thing and then some other audit company finds it, some hacker finds it, it's a really bad feeling. And there's a lot of auditors out there who have this feeling because they thought they were finding everything, they missed something. So yeah, that's one type of stress. Now the security engineer is probably being on the inside of a project. Their fear is to get a message at midnight like, hey, you up? Like we found a bug. You have to like, quickly rescue everything within minutes before the hackers do it. So that's a different type of stress. The solo auditors, they're always on Twitter shouting because they want more customers. Yeah, so they're wondering where their next clients are. And the bounty hunters just wonder if they'll ever find anything because the hit rate is so low that, yeah, you can have months with no luck whatsoever, but that's where the stress comes in. So it's not the same stress for each person, but you get to pick your favorite stress, basically. And I guess this jumps into a little bit of how security is a bit hard, because you might expect bugs in certain ways, certain formats, certain types of attacks, but there's always a greater series of possibilities than you might imagine. So the real tricky part is expanding your expectations of where the bugs are to grow to the full space where they can actually exist. So I would say that's sort of what every person working in security is striving to do, to like increase their knowledge and understanding to have the two circles match. Okay, another misconception. North Korea, they're just taking everyone's money. No one can stop them. They're like these crazy hackers you see in movies with their hoodies on in the dark room. And at least a lot of news stories would make you think this, because like every time there's a lot of money stolen, it's always North Korea. It's like you can just predict it. It's like, oh, I don't even need to read this news story. It was North Korea. Like I just know. I'm not going to comment on whether all those claims are true. I don't think we've gotten many interviews with the North Korean hackers who are like, oh, yeah, that was me. Yeah, I was so good at that one. But anyway, what I will say about a lot of these attacks is very few of them are like really clever things. A lot of them, when you read the article, when you read the post-mortem, it's like, oh, they didn't do this? Like, well, of course they got hacked. It's almost like I don't want to say they deserved it, but like, were you guys even checking with the security person? Like, this is a very avoidable thing that you could have prevented. But the other difficulty is, even if it looks simple after the hack happens, the question is, like, did it look simple beforehand? Because there's so many ways that you can have some missing piece of security in developing something that it's hard to have all your defensive shields always active. And another thing is that Web3 teams do forget about Web2 security sometimes. And I don't know if anyone here has figured out how to build Web3 without Web2. I think we're all still using the internet, last I checked. So there's some dependencies on Web2 that do need to be considered. I won't elaborate on this because this is not a talk on Web2 security, but honestly, we need to start having talks like that because a lot of hacks are getting back to this stuff. So if we can get Web3 without Web2, let me know. I really want to be using that tech stack. And just to demonstrate why I would argue North Korea is not unstoppable is a lot of these hacks happen again and again and again. And this is why when I read some reports, I roll my eyes like, yeah, it's another one of those. And this is a list. This list, I think, is actually like 1 or 2 years old. I need to get the updated version from the creator. But you can see the most common attack, we have 29 instances of this price oracle manipulation attack. 29. And probably every single one of those resulted in like, I don't know, probably average of $1 million or more lost. So I think after maybe 3 of those, we could have learned the lesson of what not to do. But no, it's 29 and counting because I can guarantee you there's more coming. So is this a problem with developer education? Is this a problem with user education? I really don't know exactly who we want to point the finger at, but we don't need 29 of the same issue to learn this is an issue. So anyway, you can look at this list here. I will point out number 4, stolen private keys. How many of you have your private key on you and want to share it now? Anyone? No? No takers? Okay. This is like not even really a Web3 thing. This is like, do you have a password that you store securely? And I will say in Web2 security, bad passwords is a common attack vector, but having these stolen, it's like you wrote it on a Post-it note. I don't even understand like what's going on here. So yeah, but if you can avoid these issues, you're doing well because these are the most common. This is another misconception. If you get hacked, you're an idiot. I'm not going to argue completely against it, but it depends on the type of vulnerability. And again, sometimes it's easy to say after, like, oh, this was so obvious. Like, no one checked this. But then other times it's like, well, they added it at the last minute, and actually no security person even looked at that line of code. So it's like, I don't know. You can point finger where you will, but I wouldn't argue this is always true, and there are always some extremely novel vulnerabilities that come about. They are rare, but I will point out that like some attacks, it's like some crazy series of 6 steps, and no one's dreamed of these 6 steps before in that order. And it's only something that could be done if the code is working in a certain way. So like somehow the hacker found the right code, the right 6 steps, and put it all together. And in those cases, like, I'm not here to congratulate the hacker, but like that took some serious effort. Like that was not a straightforward thing. Okay, last misconception. Of course, this is not a misconception. This is just reality. No, just kidding. Security jobs are the best. I will say it's also very good if you're already a paranoid person. Speaking from experience, it's a great fit for those type of people. If you're not paranoid, you'll get there. Don't worry. It's part of the evolution. Now, I will say one thing to keep in mind: the devs you work with, the developers who write the code, because you're basically telling them that they're wrong, they're going to argue that they're not wrong. Actually, they're quite smart. This is just part of the game, but at the end of the day, you want users to be happy and safe. That's the name of the game. Doesn't matter who's right. I will say one thing I learned after quite a while of doing this is that you get to a point where when you see code, you just expect there's bugs. And this can be a little bit sad at some point, because you realize that this industry, we're trying to build great things. We're trying to like change the world. It should be full of like rainbows, unicorns, Lambos, all this stuff. But now when I look at the code, I'm just like, you know, there's so many problems here. All I have to do is like prove it. Like it's going to be easy. Just give me a few days. And that's not necessarily a healthy, positive view of like we're making progress. So what I would suggest is having like some balance of looking on the developer side of what cool things are happening in the space, just so you're not too negative. Because I definitely got to a point where it was getting a bit too negative of what was happening. So yeah, I think this is a healthy thing to be aware of. But yeah, don't worry. When you're in security, you get to be the unicorn that comes and stamps approved on all the code, and you sound so cool. So this is basically what security people look like when they're having a good day. Yeah. Speaking from experience. So why is security hard? Anyone see the flaw here? This is a security test. If you see the flaw, raise your hand.
Compound code is kind of bad.
No, it's Compound v2 code. Compound v2 works. Anyone else? So there is no flaw that you can spot here, but here's a hilarious thing. You can take Compound code. Compound Finance is like a working protocol. It's been out there for a while. You can copy and paste the code, and then you can get hacked. And it's like, what did I even do? I'm using the same exact code, and I just got hacked. And the reason that this is possible, and actually it's not just possible, here is all of the incidents of this happening. It's not like one person did it and they got hacked. It's like 1, 2, 3, 4, 5, 6. Yeah, I'm not even going to count, but about a dozen. So all these times they just copied, pasted the code. Maybe they changed it a little, and in those cases I would have said like slap on the wrist or whatever, like at least get an audit. But there's a lot of assumptions baked into the code. And if you're doing a parameter change, it's not actually changing the code, it's changing the value stored in the code. It's like a setting that you're changing. Maybe the governance is changing something. And if you don't know exactly what you're doing in those cases, you can completely destroy what you've built. And clearly that's not a good way to go out. So anyway, if you're copying and pasting code, you need to also understand the code as well as the original developers. And that's super hard to do because the developers that wrote the code, they ran into bugs. They had to add fixes to work around these bugs. They understand like all the edge cases from writing the tests. And most people that copy and paste, they're not the type of person to put effort in, sadly. So am I saying you should avoid copy-pasted code? Maybe. It depends if you trust the developers to actually do the work to understand what they're doing properly. But this is just one example of how security is hard. Because you can look at the code and they say, we just copied and pasted, and you can verify that and say, yep, you copied and pasted, but there can still be problems. This is an example actually from a real audit. using Compound v2 code. So we'll have a real-world example. If you've heard of Aave, it's a rather large protocol in the space. You basically can deposit a token and get some yield. And the way that the yield percentage is calculated is with like a two-piece defined curve. And here we actually have the curves for DAI on, I think this was on mainnet, for Aave, for Compound, and for an unnamed protocol. And there's some divergence here. I'm not going to comment whether this divergence is good or bad, but there was no explanation from the developers about this divergence. It was just like, well, we picked some numbers. And if you don't understand what you're doing with important parameter changes, I would argue that's bad. I don't know if it's like something that can get hacked tomorrow bad, but it's not good. So anyway, just one example. And also you can see that Compound and Aave basically overlap until a certain point, and then they both split off at the same point. So anyway, just another question that the developers didn't really have a great answer to. Anyone spot a security issue here? Potentially. It's not an immediate security issue, but. Okay, this is really hard. I didn't really have a specific answer in mind. You want censorship? That's not a security issue.
Well, it can be.
Okay, it can be, yeah. So we could say denial of service, basically, would be the security equivalent. All that I did here was take a screenshot on Etherscan of different blocks being mined, and you can see that it's the same recipient or same block builder for many blocks in a row. And one possible issue here, well, I guess there's quite a few, is if you have the same block builder many blocks in a row, this person can potentially do some MEV, some minor extractable value, to move transactions around in these blocks to extract profit. And one thing that I think so far has been rather hypothetical is manipulating certain on-chain oracles, especially the decentralized kind. So if you're using Uniswap for price data, even their TWAP, which is like supposedly a secure oracle they have, if you can do some funny business for many blocks, you can actually alter some of the assumptions and the values of these oracles. And that basically lets you change the price of an asset, which is pretty dangerous. Sorry, was there a question?
Yeah. I just wanted to ask which chain is this?
This is mainnet, yeah. Yeah. And actually, I think there was one place I found 7 in a row, and this was on the first page of searching.
I mean,
yeah.
I would have thought that like proof of stake would not allow this to happen.
It actually allows it to happen more, sadly.
Oh, I see.
Yeah. So I hope everyone sleeps well tonight. You have a comment?
Technically, Beaverbolt is not a single block builder.
Okay.
It's a bundler. So there's going to be multiple block builders that send bundles to Beaverbolt.
Okay.
And
Yeah.
Beaverbolt will rank them based on how much MEV they extract, and then include the highest MEV extracted one.
I am making this look a little more scary than it might be, but there's still some scary stuff here that is worth paying attention to.
Share is like quite high, so they can definitely do
Yeah.
many attacks.
I think it's getting close to 50% if it's not there already. So yeah, sleep well. Okay, another just random point of why security is hard. Does anyone know this EIP 1559? Sound familiar to anyone? You might have heard of it some years ago, way back in prehistoric days if you're on mainnet. So this EIP was at the time considered a pretty big deal, and it was changing something related to the gas fees and burning ETH. But what I want to point out is a lot of people are aware of these L2 chains, and these L2 chains are trying to provide something like the same experience as Ethereum mainnet, but cheaply. And a lot of people put their code on mainnet and also on these L2 chains. And what you have to realize is these chains are not actually the same. So if you're putting the code, the same code, on different chains, you have to know the differences of the chains. And even though this EIP made it to mainnet Ethereum in 2021, it didn't go to Polygon until the next year. Took another year to get to Optimism. BNB took longer. So basically, any EIP that exists that arrives on mainnet, you cannot assume that it's going to arrive on the L2s until some later point. And this actually became a slight issue recently with a new opcode, push 0. So if you compiled the code, it actually wouldn't run on some chains because it's using something that doesn't exist there yet. So anyway, Ethereum itself as a blockchain changes over time, and you have to factor that in if you're using multiple chains. So anyway, just another explanation of how security can get a bit annoyingly difficult. So what does the future hold? I haven't shared anything like this before, so you're getting some unique alpha perhaps. I think there's actually a lot more room for security work in this space that is not yet tapped into. And actually some of these I already know there is some demand. People have been pinging me asking who can do this stuff, and I just don't have a good answer yet. So I'm not gonna, I guess I can read these out very quickly, but people who are specializing in wallet security, there's a lot of wallet issues out there, but not many people are specialized in this. Front ends. The front end for the dApp can have security issues. Even DNS can have security issues, how you register the domain. There aren't people that I know that are specializing in the networking sides, like how the actual nodes are communicating. DeFi protocol specialists, there's so many protocols of a single type now that you can just specialize in one. Post-deployment monitoring, so just because you put your code on chain doesn't mean your job is done with the code. You have to do some monitoring, and especially when you're making updates or governance changes. Blockchain-specific specialization. Some blockchains are just different. They're like really different. So having a specialization in one can actually be a full-time specialty now. There are some tools that are just hard to use, and having someone specialize in that can be good. And actually this one, there is a direct Web2 security analogy to this one, where like if you get hacked, then what? In Web2 security, there are literally companies you call like, hey, I got hacked, bring in your team. And then like the team just shows up. And we don't have anything like that for Web3 yet, but I think this is unfortunately something we need because these hacks still happen. So anyway. Okay, so a quick summary of what I talked about. So I gave you an overview of the landscape and how it's changed in the last 5 years. I shared some misconceptions. Maybe you learned a little bit more about Web3 security, or at least got some laughs. And then even though security is hard in a number of ways, I think there's more and more avenues that can exist if you're interested in getting into this space. And also if you are worried about using the technology in the space, I think that more and more people will onboard into these niches to help, let's say, solve some of the issues we are seeing today. So hopefully overall it's a relatively positive message as opposed to the scary headlines that I started the talk with. And that's all.
Thank you, engineer. Ask me anything session starts now.
So yes, I will be open to any questions at all, so go for it.
Yeah, how deep does the security engineer need to go? Because if you're looking at the code just, for example, in Solidity, that's abstraction upon abstraction upon abstraction. There is a compiler. Does he need to know the bytecode and how it works, and what is the limit that you need to go, how deep before you can say this is secure?
Well, I want to just mention one security thing quickly for those of you who did pull out your phones to scan the code. No doubt you found you've been rickrolled. Serves you right. This was a test. You just didn't know it yet. Okay, I had my fun. This was actually a suggestion the last time I gave a talk with the QR code, so it's not from me. So I'll just repeat the question now that I've distracted everyone. You can get rickrolled if you want to, by the way. QR code will stay. So the question was, how deep do you need to go? Because it's almost like diving down rabbit holes when you look at code. You can look at the Solidity code, you can look at the bytecode, you could look at the compiler, you could look at like literally every piece of the tech stack, and it's a really tall stack. So I don't have a perfect answer. I can of course tell you how it works today, but I'm guessing one of the reasons that you asked this question is there have been vulnerabilities due to compiler bugs in the past. I think the most well-known one was a Viper bug. Was that roughly a year ago, I think? I may have seen perhaps only the second bug of that type in the last couple months. It was, I think, fuel chain or something gas, I don't know. But it was like a compiler I'd never used myself. I just saw on Twitter someone found a bug in this. So I think more and more this will be a concern. And a compiler bug for a language like C, it can sometimes lead to, say, a Linux vulnerability, a Windows vulnerability. But if it leads to a DeFi vulnerability, it's like immediate monetary loss. So it's a lot more obvious what the impact is. Everyone can see it on chain. Everyone sees the stories. So I think at the end of the day, any question about what the security people should do has to factor in like the effort and cost as well. You can get an extremely comprehensive audit of your code. It's going to take maybe a year and hire a team of 10 people, and I don't know if anyone really wants to pay for that cost. So the real problem is right now we have all these like cost trade-offs, and if you choose something that's suboptimal, then you get hacked. And it's like, I didn't realize I was going to get hacked. If I knew I was getting hacked, I would have paid a bit more up front. Like that's the typical approach, I think. So yeah, there really is no good answer. I think what could be done is looking at what I always do in this Web3 security space is I try and find analogies to Web2 security where I was before. Because Web2 security has existed for much longer than Web3 security. And if I can steal some ideas of what evolved over there, and then I look at Web3 where it's going, and I'm like, oh, so the next step is this. It's like I'm just looking at what happened in Web2 at that point of evolution, and we can see potentially the exact same in Web3. So I think that's one way to approach things. I will say if you use that approach, there actually aren't many good resources in Web2 security because no one actually reads all the code in Web2, unless you're talking about nuclear power plants or NASA. And even NASA's had a bug that crashed a rover where I think they didn't convert like feet to meters or something ridiculous. It's like, come on, even you guys. So it's interesting how even though we have all these hacks, we might already be in many ways better than Web2 security, which it doesn't look like it. But I will say one reason that you might think it looks like Web3 is worse is because a lot of Web2 hacks you never even hear about. Like, how many of you have actually heard about a big Web2 hack with a bank? Anyone? Does anyone think that all banks are actually fully secure? If you're also asking questions about what you've heard with Web2 hacks, there's one point I love to bring up, which is how many of you have seen a headline of like North Korea hacking something, China, Iran, Russia? It's the usual suspects. You've seen these headlines, of course. Now, how many of you have seen a Western government hacking a headline? Anyone? No? No comment. So yeah, I think Web2 can serve as an analogy for some extent, but we are forging a lot of new ground. So yeah, no good answer yet. Yes?
How effective are AI tools getting at code review, and do you think they're going to replace some aspects of security auditing?
Yes, this question. So I've been asked by non-tech people if they're worried that AI is going to steal my job, and I laugh. I'm like, do you know how many bugs we find in this code? Like, if the AIs do it, I'll just look for bugs in the AI code and have a new job. So yeah, I'm not particularly worried about that aspect, but how useful they are for smart contract code. what I often tell people is that AIs are trained on existing data from the web, and some of these vulnerabilities, there's like 2 blog posts that write about them. So unless the AIs can somehow pull these correct 2 blog posts at the exact right moment they're needed, I think the lack of data online is still a bit of like a problem for the AIs to leverage in this domain. I think they will improve, and of course training an AI specifically on, let's say, the right information sources could help. But for me personally, at least to the extent I've seen public research, there could be private research that goes well beyond what I've seen. I think the AI tools still lack some of the nuance of the space. For common vulnerabilities, they definitely can spot some issues, which is great. I think that actually means there's even less excuse for the most common bugs, which like on this list. So if you're gonna get hacked by one of these bugs at this point with some AI tools, like come on, like really, there's 29 other people that had the same exact lesson. AI can probably pick it up now and you did nothing. So I think from this perspective, hopefully it will be reduced on the common issues, but the more rare issues are difficult. And I will also give one puzzle of like some of the security issues. Trail of Bits wrote a report that some of the issues, it would take AGI, so generalized artificial intelligence, to actually find them. So I think it was like, yeah, half the issues. So even if we had really good AI tools, it couldn't find half of them. And I'll give one example of like how you'd even like try to get an AI to detect a bug. So let's say you put $100 into some code, and then after 1 week you pull out $101. Is there a bug? Because you just got out $101. You only put in 100. Where did the $1 come from? So this is the sort of thing where it's like, maybe AI has enough logic to like rationalize about what the code should do and say, well, actually you were only supposed to get $100 and a half, but taking out 101 is too much. But that's really hard. You have to like teach the AI exactly what the code should do, and then it matches what it should do with what it is doing. And I think at this point we're getting closer to formal verification, where you write a specification, exactly what the code should do, and then match it against the code. And I have to tell you, from looking at many code bases, no one writes that documentation so well. It's like, there was one project I looked at which had really good documentation, and it was like a friend of mine who knows my annoyance at documentation, and I think I kind of like pushed him to do better. So yeah, I think there's room for these tools. They're still early. And if we start seeing people train the AIs on the correct data, I think there could be some more interesting stuff that happens. I don't know if we've gotten there yet, but hopefully soon.
Yeah, a question about tooling in general. So for someone coming into the space, do you think there is some like tooling or frameworks that people should learn how to use if they want to be better at security? Because like in Web 2, it's very common to use a lot of tools for quality control and for finding bugs and stuff like that. But in Web 3, it's not that common. So if you want to be a security expert, should you just focus on learning how to do things and do it slowly and carefully and be correct? Or should you focus on like removing human error and speeding things up and stuff like that, just in your experience?
Yeah, I think I can answer this from 2 perspectives, and it depends on your role. So if you're a developer, you shouldn't be wasting too much time on learning security in full detail. Like from the developer perspective, you want to have some continuous integration, some automated scanning to detect the obvious bugs. So from this perspective, the tooling can be useful. And there are some, or at least one, I think, GitHub action from Trail of Bits to run Slither on your code, so I'd recommend doing this. But from the security perspective, if you're actually trying to find bugs, I think I would personally recommend, especially while you're learning, the full manual approach. I will even say from the Web2 security side, some people who are on these bug bounty platforms, where you basically are just clicking around a website and then looking at the code and trying to find a bug, and they actually live stream this. When you watch their process, they do have, like, they know about all the tools, but the majority of what the experts in Web2 security do is just like manual. Like, they just know exactly what to look for, and the training for that only comes from manual effort. So if you're letting the tools do the thinking, you don't always understand the logic. So if you want to be fast, be a developer, use the tools. If you want to really learn security deeply, go full manual. It's like someone driving a car. If you're lazy, go with automatic. If you really want to be a race car driver, get the manual.
Great talk. Thank you so much for talking. I worked in the same field at a company called Entity Group Crypto Services.
Yes.
And I felt exactly the same about many things you said. So I guess my question is about Code Arena. Do you think it's a better strategy to learn Solidity and focus on Solidity, or ignore Solidity and just focus on other types of projects?
Yeah, that's a good point. In fact, if we go to the contest page, I will say for anyone who wants to know the website, I think I tried to include the URL. So if you want to do contests, that website aggregates different contests. So I'm just looking here if they specify which language on this screenshot. I guess not. I will say, just to add to the history of security in the space, like the last 5 years, let's say Code Arena 3 years ago, it was only Solidity, like only Ethereum blockchain code, smart contracts. Now they have basically anything. There can be Rust code, there can be just normal Web2 code. It goes all over the place. So I think from the current perspective, you really have to judge based on how many contests there are in different languages and what your skill set is. I think there is a lot of opportunity doing non-Solidity stuff if you already have some skill. If you only learn Solidity, like that's the first coding language you learned, then maybe it's not recommended to branch out because there's a lot of fundamentals you need to learn. But yes, I think today the landscape has changed from even a year ago, and that's definitely a very valid thing to think about if you have coding skill in other languages. I will say, speaking from experience, it does seem like there's much less attention paid to Rust or other contest languages. Yeah. Good observation. This is just a demonstration of how quickly the space changes, because a year ago it was completely different. Like a year ago, there was maybe 2 or 3 contests that were not in Solidity, but now the game has changed. And even some of the rules on the contest websites has changed. So there's a lot of like optimization to be done, let's say. Yes?
Yeah, I heard recently that a lot of big brand security companies are actually one of the worst at doing security audits, and then the smaller, lesser known companies are much more effective. How accurate is that?
Yeah, this is also a great question because it depends on the people working there. And at one point, I knew that a lot of people had changed from different companies, and so people were asking me, like, who should I get an audit with? And I just had like a list that I copied and pasted to different people in Telegram. Like, this one's good, but like 2 of their top people just left, so like maybe wouldn't recommend it. And this is where having some of the insider knowledge can be a bit helpful, because let's say if you're on crypto Twitter but only following security people, and you see like, this guy was really good, he just moved to this company. Oh, and this person from a different company also moved there, so maybe this new company is one to watch. I would say this is like very volatile. I think at one point when there were huge backlogs, when was this? I think I said 2022, there was a lot of hype over we need the audit done by this big name company. And they had really long backlogs. I will even name a name, Trail of Bits, I think specifically had like 4 to 6 month backlog at some point. But I think since then, and especially with shorter audit backlogs now, it demonstrates that like the market is saying that there isn't a single audit firm that's considered the best anymore. There's probably, I mean, I guess I should be promoting ones that I think are good, but I'm not going to. You can DM me if you want suggestions, anyone. Although I guess my knowledge is not as accurate as it was like a year or 2 ago when I was much more locked into where everyone was. I think now it is like just recommended to do more than one. is
Yeah.
maybe one of the changes. Because before it was like, do one, make it a really big name and you're done. And now it's a bit more of like a diversification approach. I think famously, Euler Finance did over 10 audits on their code base, which is, from the cost perspective, absolutely insane because it was like $2 to $4 million spent for their code. But due to their history, they wanted to be secure. So, and they are doing security very seriously.
Is there a way to kind of evaluate these security companies if you don't have insider knowledge?
No. Yeah. I will say what I do from the outward-facing sides. Like if I don't know where people have moved to different companies, you can look at their audit reports and judge based on that. But that also requires like a security person's knowledge to judge like, oh, this company, the findings in their reports are just generic stuff. Whereas this audit company, I read their report and it's like, wow, those were really hard to find issues. So I don't know if you consider that insider knowledge, but at least like security knowledge to judge the reports. I will say at one point, I was trying to do, actually, what year was that? Was that last year? Last year I was trying to do an initiative to judge audit quality, but it didn't get too far because it's really hard to create metrics around this. So the closest I could get was how many findings per report any audit company would publish and then average it across many reports. So if one audit company publishes like an average of 3 high findings per report, that might be better than 1 high finding per report. But then you have to see if anyone is gaming the system by elevating findings. You have to think about the quality of the code that they're getting. Maybe they only get really good code at this company, and so there's less findings. So I've thought a lot about this, but and I actually made some graphs for this attempt, and then those graphs got circulated around like, oh, this is how it is. These are the best companies. It's like, no, you have to consider all the other variables, but no one did that because it's Twitter. So yeah, it's hard, is all I can say. Okay. Any other questions? If not, you can catch me after the break, and I'm often around, so just ask if you have any security questions. Okay, that's it.
Engineer.
Thank you.